All right, and we are on to problem 3, and let's go ahead and do some hypothesis testing. We cleared our notebook, but I'm going to bring in some functions that I'm going to need in order to start to solve this problem. I don't need that, number 1. Let's go ahead and evaluate these. Let's start to list out some variables. So I test 27 samples of product 1. So I do n1 is equal to 27. I can do that my x of 1 is equal to 47. Oops. And then I gotta do my S1 is equal to 0.1. My number of 2 is equal to 57. My X of 2 is equal to 49. And my S of 2 is equal to 1. And then my microwave is going off. Instead of S2, I want to make it equal. And then my N3 is equal to 8. My X3 is equal to 45, and then my S3 is equal to 5. Excellent. So I can go ahead and start to figure out the first problem. So we're going to have to do a hypothesis test. It's going to be a two-tailed test. We're going to do our t-test expression. So I'm going to do, basically, are they the same? So are products 2 and 3 the same, frequency the same, frequency is different? We're going to work at 90% confidence interval. So product 2, so I need x2, and then I need x3, then I need S2, and I need S3, and then I need N2, and I need N3. That's going to be my t-squared experimental. I need to define these here. Give me the numeric answer, not the symbolic answer. That's my t-squared experimental. My nu is going to be equal to S2, S3, N2, N3, based on that expression. So now, what's my t alpha over 2? So my t of 0.05, and my nu of 7. So again, I can look that up in my table. T of basically from 10.05, nu of 7, that's 1.895 equals 1.895. And then now I could do my hypothesis test. So it's a two-tailed test. So are we in the middle? Are we less than, greater than? Let's go ahead and check it out. So right here, so we are out of the bounds, so we are going to be saying for this one, reject. Because again, those fall our bounds, so we're outside of our bounds for our two-tailed test. So they are different. All right, next one. Does product 1 come from a population with a mean of 46.8 nanometers at a 99% confidence interval? So I could actually solve this problem by looking at my T alpha over 2 is going to be T005. My nu is going to be, from product 1, it is going to be 26. So I can find that value here, because I'm going to use that to calculate basically my 99% confidence interval. Because we're asking, does it come from a population with a mean of this? So I could estimate that population mean using my X bar equation. So I need 005, and then 005 here, and I need to do 26. So 2.779. 2.779. So I could do T005 nu 26 times S of product 1 divided by square root of N1. And I could get that, and I need basically my X. Let's go ahead. Oops. Let's put that. It'll be the same. So I need my X1 plus this. And I could look at my X1 minus this. And so does it come? Nope. So it does not come from that population mean. Would a measurement of 47.4 nanometers be an outlier? So all we'd have to do is basically look at x1 plus 3 times s1, x1 minus 3 times s1, because that's our calculation for an outlier. So 47.4, absolutely. 46.8, also, actually, it had to be less than, so that is not an outlier. Great. Now, does product 3 come from a population with a mean greater than 46 at a 90% confidence interval? So again, this is a right-tailed test. So I'm going to use my T1. So T1, and actually, we can solve it up here. T1 is going to be my X bar. So again, it's X3. What is my mu naught or my H naught? It's just going to be 46, because that's what we're hypothesized testing against. S3 and 3. That's my t-squared experimental value. what is my, again, I'm looking at 90% confidence interval, so it's going to be T alpha, not alpha over 2 because it's a right-tailed test, so it's going to be 0, 1. My nu is going to be product 3 is going to be 4. So I can go in again, right here, 0.1, 90% confidence interval, because we're not divided by 2, 4, 1.533 equals 1.533. And again, we're asking, does it come from a population with a mean greater than 46? So we're doing a right-tailed test. So right-tailed test, we saw that our value here is 1.533, and our t-experimental is less than that, so we are in the what region? Do not reject. And then finally, does 2 come from a population with a mean less than 50? So again, very similar problem. Left-tailed test though this time. So again, product 2, x2, mean less than 50, right here, s2, oops, s2, oops, and 2. So that's my t-value. What is my 95% confidence interval? So again, it's t of 05. My nu, for a number of 2 samples, I'm going to just say infinite. So I'm going to go here, t of 05, infinite 1.645. If I'm doing a left-tailed test, oops, that's calendar. If I'm doing a left-tailed test, I need to have negative that value. So minus 1.65, but we're still way over to the left there, so we are doing reject on that one for sure. So this one will be basically reject. And that's it. So that's that problem. So again, not too shabby, done in 7 minutes. So we can do this. All right, I'll see you all on the next problem. Thanks.